The Solomon Islands do not appear on most maps of consequence. 900 islands scattered across a stretch of the southwestern Pacific so remote that the nearest continent is over 1,000 miles away. The people who live there are among the poorest in the world. The islands themselves are among the least visited. For most of recorded history, the outside world paid attention only when it needed something: land, labor, a strategic airstrip. It looked, took what it wanted, and moved on. What it never thought to look for was the one thing the Solomon Islands actually contained that no other place on Earth could offer. Buried inside the DNA of the people who have lived on these islands for 30,000 years is a genetic signal that has forced scientists to rewrite the entire story of how modern humans spread across the planet. The ocean kept that secret for a very long time. To understand what the DNA revealed, you first need to understand who the Solomon Islanders actually are and how long they have been there. Melanesia is not a country. It is a region, a cultural and ethnic designation covering a sweep of islands, stretching from Papua New Guinea in the west through the Solomon Islands, Vanuatu, Fiji, and into the smaller territories beyond. The people who share that designation share something older than nationality, older than language, older even than the cultural traditions that outside observers have spent centuries cataloging and marveling at. What they share is deep time, a presence in this part of the world that predates almost every other settled human population outside of Africa by a considerable margin. The first humans to reach the Solomon Islands did not need boats. That fact is worth pausing on. 30,000 years ago, the geography of this part of the Pacific was fundamentally different from what it is today. Sea levels were significantly lower, and the land masses that are now separated by open water were connected or close enough to be reached by people moving through a landscape that no longer exists. The islands were not islands. They were the eastern edge of a continuous landmass that included what is now New Guinea and Australia, and people walked to them, or crossed only the narrowest of gaps, following routes that the ocean has since swallowed entirely. When the last ice age ended and sea levels rose, those land connections disappeared. The people who had walked east found themselves on islands. They had not gone anywhere. The world had changed around them. That founding population stayed. For thousands of years, the islands were theirs entirely, a world of small villages, subsistence farming, fishing, and trade between island groups. No centralized authority, no single language. Cultural traditions and spoken dialects varied from island to island and sometimes from village to village within the same island. What held the population together was not political organization, but something older and more durable. Shared ancestry, shared presence. The accumulated weight of 30 millennium of continuous habitation in the same place. Then, around 1200 BC, something changed. A new group of people arrived. The Austronesians, a term covering a broad range of seafaring populations who had originated in what is now Taiwan, had been expanding outward across the Pacific for generations. They were extraordinary sailors, carrying with them a distinctive material culture that archaeologists would later identify through a particular style of decorated pottery known as Lapita ware. The specific group that reached the Solomon Islands came through the Philippines and into Melanesia, and they were not simply passing through. They stayed, and in staying, they encountered the people who had been there for 28,000 years before them. What happened next was not replacement. It was mixture. The Lapita arrivals and the long-established Melanesian population interbred over generations, producing the ancestral population from which modern Solomon Islanders descend. That admixture is written into every genome on the islands today. It is the biological foundation of the present population, a layering of ancestries that begins with the Ice Age and accumulates forward through millennia of contact, settlement, and intermarriage. This is not unusual in human history. Almost every population on Earth carries the genetic evidence of multiple ancestral streams converging over time. What makes the Solomon Islands different is what those streams contain. Because buried inside that founding Melanesian ancestry, the component that stretches back 30,000 years to the people who walked east before the ocean rose, is something that scientists did not expect to find, something that does not appear at anywhere near the same level in any other population on Earth. And when ancient DNA finally gave researchers the tools to see it clearly, the implications reached far beyond these islands. The anomaly had been sitting in the data for years before anyone fully understood what they were looking at. When geneticists began mapping human population diversity across the Pacific, the Solomon Islands kept producing numbers that didn't align with the standard model, not slightly off, genuinely, measurably different in a way that demanded explanation. The signal they were seeing wasn't from any known modern human population. It was older than that, considerably older. And it pointed towards something that at the time the first traces of it were identified, science had only just begun to recognize as real. Denisovans. The name comes from a cave in Siberia, the Denisova cave in the Altai Mountains, where in 2010 researchers extracted DNA from a finger bone so small it could sit in the palm of a child's hand. The bone belonged to a young girl. She was not fully human, not in the way that term is usually applied. She belonged to a distinct archaic human lineage, a sister group to the Neanderthals, that had split from the lineage leading to modern humans hundreds of thousands of years earlier. The Denisovans were real. They had lived. And then, like the Neanderthals, they had disappeared. Or so it seemed. Because the DNA didn't disappear. It survived, carried forward in the genomes of modern humans who had interbred with Denisovan populations before those populations vanished from the fossil record. In European and Asian populations, the Denisovan signal is faint, a fraction of a percent, barely detectable against the broader background of modern human ancestry. In the Solomon Islands, and across Melanesia more broadly, the signal is not faint at all. It is the highest concentration of Denisovan ancestry found anywhere on Earth, running at levels that made the initial findings difficult to accept and impossible to ignore. What the ancient DNA analysis established, with increasing precision as sequencing technology improved, is that this is not residual background noise. It is not a faint echo of distant incidental contact. The Denisovan ancestry carried by Solomon Islanders is structured and substantial, and the genetics point not to a single interbreeding event, but almost certainly to multiple separate encounters between ancestral modern humans and distinct Denisovan populations at different times, in different locations, over the course of the long migration eastward through Asia and into the Pacific world. That detail matters enormously. Because the Denisova cave is in Siberia, the ancestors of Solomon Islanders did not come through Siberia. They came through Southeast Asia, moving east and south along a coastal migration route that the standard out-of-Africa model had sketched in broad strokes, but never fully resolved. The presence of substantial Denisovan DNA in Melanesian populations, but not in the populations of Europe or East Asia, means that the Denisovans were not confined to the cold interior of the Eurasian continent. There was at least one other Denisovan population, geographically separate from the Siberian one, living somewhere in Southeast Asia or the islands immediately to its east. Modern humans moving through that region encountered them. They interbred. And the biological record of those encounters survived 30,000 years of history inside the genomes of the people now living on islands most of the world has never thought about. The standard model of human dispersal out of Africa did not account for this. It could not have. The evidence didn't exist until the DNA of the Solomon Islanders was examined closely enough to reveal what it actually contained. What it contained was the biological proof of a chapter of human prehistory that had left almost no trace anywhere else. No fossils, no tools, no art. Nothing but a genetic signal, preserved in the most remote corner of the Pacific, waiting for science to develop the tools to read it. The question the genetics raised next was where exactly the interbreeding happened, and where, in this case, is the detail that quietly dismantles the version of human prehistory most people had accepted without ever examining it closely. The Denisova cave sits at roughly 50 degrees north latitude, deep in the Siberian interior, thousands of miles from the nearest tropical coastline. The ancestors of Solomon Islanders never went anywhere near it. Their migration route ran south and east, hugging coastlines that are now mostly submerged, moving through what is now India, Southeast Asia, and eventually into the island chains beyond. If the Denisovan signal in Melanesian DNA came from a population centered in Siberia, the geography makes no sense. The distances are wrong, the routes don't connect. Something else had to be true. What the genetics strongly suggest is that the Denisovans were not a single population occupying a single territory. They were widespread, diverse, adapted to different environments across a vast geographic range that stretched from the cold forests of Siberia south through Asia and into the tropical regions beyond. The population whose DNA survives in the Solomon Islands was not the Siberian Denisovan. It was a separate southern group, living somewhere in Southeast Asia or near Oceania, that has left almost no fossil evidence whatsoever. A population that existed, that was real enough to meet and interbreed with modern humans on multiple occasions, and that then vanished so completely from the physical record that science had no idea it had ever been there until the DNA of living people revealed its shadow. That absence is itself a finding. The fossil record of Southeast Asia and the Pacific Islands is sparse and difficult to interpret. The climate works against preservation. The geology is unforgiving. Bones that survive for tens of thousands of years in a Siberian cave do not survive as readily in the humid tropics. What this means is that the Denisovan presence in Southeast Asia was archaeologically invisible, not because it didn't exist, but because the conditions for finding it were never in place. The Solomon Islands genome found what no excavation had managed to locate. The implications for the out-of-Africa model are significant. The standard account describes modern humans leaving Africa, moving through the Middle East, and then dispersing across Eurasia in broadly separate streams, one heading northwest into Europe and one heading east through Asia. What the Melanesian DNA establishes is that the eastern stream was not moving through empty territory. It was moving through a landscape already occupied by archaic humans who were genetically distinct from the Neanderthals encountered further west, and it was interbreeding with them. Not once, but repeatedly, at different points along the route, with different Denisovan populations carrying their own distinct genetic histories. The comparison with Neanderthal ancestry in European populations makes the point with unusual clarity. Most people of European descent carry somewhere between 1 and 2% Neanderthal DNA, the residue of interbreeding events that occurred as modern humans moved into Europe. Melanesians carry Denisovan ancestry at levels significantly higher than that. The encounters were not marginal, they were not brief. They were sustained and frequent enough to leave a mark in the genome that 30,000 years of subsequent human history has not diluted away. And there is a further layer. The Denisovan ancestry in Melanesian populations is not genetically uniform. Analysis suggests it derives from more than one source population, meaning the ancestors of Solomon Islanders did not encounter a single group of Denisovans at a single point in time. They encountered different Denisovan populations in different places across a span of thousands of years. Each encounter left a trace. All of those traces converged in the islands, and the people living there today carry every one of them. To understand what the Solomon Islands genome does to the Lapita story, you first need to understand what the Lapita story was supposed to be. The Austronesian expansion is one of the great movements of human prehistory. Beginning in Taiwan around 4,000 years ago, populations of skilled seafarers began moving outward through the Philippines, into Indonesia, across the islands of Melanesia, and eventually into the remote Pacific beyond. They carried a recognizable material culture with them. A distinctive style of decorated pottery, geometric and precise, that archaeologists began finding across a vast stretch of the Pacific world and eventually grouped under a single name, Lapita. The pottery became the marker. Wherever it appeared, it indicated the presence of people connected to this expanding Austronesian network, and it appeared across an enormous range, from the Bismarck Archipelago in the west to Samoa and Tonga in the east, tracing the outline of an expansion that linguistics, archaeology, and eventually genetics all agreed had really happened. The Solomon Islands sat directly in the path of that expansion. The Lapita people came through. The pottery is there. The linguistic evidence is there. For a long time, the assumption was straightforward. The Lapita arrived, mixed to some degree with whoever was already present, and the modern population descended from that mixture in roughly equal measure. It was a clean enough story. The DNA made it considerably more complicated. Ancient DNA extracted from early Lapita burial sites produced a result that surprised almost everyone working in the field. The individuals buried with Lapita pottery, the people who made it and carried it across the Pacific, showed almost no Papuan or Melanesian ancestry at all. Genetically, they were something close to pure Austronesian, tracing their ancestry back through island Southeast Asia without significant admixture from the populations who had inhabited Melanesia for tens of thousands of years before them. They were not a mixed population. They were genetically distinct from the people already living on the islands they were moving through. And yet, modern Solomon Islanders carry overwhelmingly Papuan-related ancestry. The Lapita genetic signal, so clear in the ancient remains, has been almost entirely absorbed. In the genomes of people living on these islands today, the Austronesian component is a fraction of what the early Lapita individuals carried. The long-established Melanesian ancestry, the component stretching back to the Ice Age founders, did not get replaced. It won. Numerically, demographically, generation by generation, over thousands of years of intermarriage, the existing population's genome gradually subsumed the Lapita contribution until only traces of it remained. This is not replacement running in the direction the original model assumed. The Lapita people were not absorbed into a vacuum. They encountered a population that had been accumulating in place for 30 millennia, and over time it was their genetic distinctiveness that dissolved rather than the other way around. The people are still there. The pottery tradition faded. The genes of the people who made it were folded into something older and larger than themselves. What this means for the broader Pacific story connects directly back to the Polynesian origins question. The admixture event that produced ancestral Polynesian populations, the founding moment when Austronesian-related and Papuan-related ancestries came together to generate something new, happened in this region. In the islands of near Oceania, among populations whose genetic history the Solomon Islands preserves in unusually clear form, Polynesian ancestry was not assembled somewhere abstract and distant. It was assembled here, in the precise biological context that the Solomon Islands genome now allows scientists to reconstruct in detail. The Solomon Islands are not a corridor that more important populations pass through on their way to somewhere else. They are the location where one of the most consequential admixture events in Pacific prehistory actually occurred. The DNA does not allow any softer version of that conclusion. The people carrying this genome have not had an easy history. That is an underestimation significant enough to require acknowledgement before moving past it. The first European to see the Solomon Islands was a Spanish explorer named Álvaro de Mendaña, who arrived in 1568 and named what he found after the biblical King Solomon, convinced he had stumbled onto an island chain of extraordinary wealth. He had, in a sense, though not in any way he was capable of recognizing. He came back in 1595 and attempted to establish a colony. It failed. He and most of his colonists died from disease. The islands were left alone for another century and a half before British and French sailors returned, and regular contact with the outside world was not established until the 1800s, when whaling ships began stopping to trade for supplies. What followed regular contact was not prosperity. It was devastation of a particular and deliberate kind. Beginning in the 1840s, a practice known as blackbirding took hold across the Pacific. Ships moved through the smaller islands, recruiting laborers for plantations in Australia, Hawaii, Fiji, and as far away as South America. When recruitment failed, which it frequently did, the ships resorted to abduction. Entire villages were taken. The people seized were transported to plantations where they were subjected to brutal working conditions, inadequate food, and routine violence. They were nominally classified as paid workers. In practice, many were never paid at all, and those who were received amounts so small as to constitute mockery. Blackbirding continued into the early 20th century. The population disruption it caused was profound and lasting. The Solomon Islands became a British colony in 1893, administered with minimal investment and considerable indifference. Then, in December 1941, the Pacific War arrived and the islands were transformed overnight into a theater of conflict that had nothing to do with the people living there. Japan occupied the archipelago. The United States Marines landed on Guadalcanal in August 1942 and began a 6-month campaign of extraordinary ferocity to take it back. 20,000 Japanese soldiers died. Thousands of Americans died. The waters between Guadalcanal and the Florida Islands accumulated so many sunken ships that the stretch was nicknamed Iron Bottom Sound. The Solomon Islanders themselves, whose land this was and had been for 30,000 years, found themselves caught inside a war between foreign empires fighting over strategic geography they happened to occupy. Not entirely passive, though. Throughout the campaign, Solomon Islanders served as coast watchers, providing intelligence to Allied forces at considerable personal risk. One man, Jacob Vuza, was captured by Japanese troops, tortured and bayoneted, and still escaped back to American lines to warn of an impending attack. He was awarded the Silver Star by the Americans and a knighthood by the British. For decades, contributions like his were minimized or overlooked entirely by the historians who wrote the war's official record. Independence came in 1978. It did not bring stability. The following decades produced a succession of short-lived governments, ethnic conflict between communities on Guadalcanal and the neighboring island of Melanesia, a civil war known locally as the Tensions that lasted 5 years and killed over 200 people, and an ongoing struggle with poverty so entrenched that more than 75% of the population still depends on subsistence farming or fishing to survive. The reason this history belongs in a discussion of DNA is not incidental. It is the point. The population carrying the most genomically significant ancestry in the Pacific world, the people whose genes contain answers to questions about human prehistory that cannot be found anywhere else on Earth, spent the last 4 centuries being enslaved, colonized, bombed, and marginalized. The science almost didn't happen. The knowledge almost wasn't recovered. And the people who made it possible are still, by almost every measurable standard, among the least resourced and least heard on the planet. What the Solomon Islands genome has rewritten is not a footnote to human prehistory. It is several of the chapters that everyone thought had already been settled. The route of human dispersal out of Africa through Asia was understood in broad outline before the Melanesian DNA findings arrived. Modern humans left Africa. They moved through the Middle East. They spread east and west across Eurasia. Some of them kept going east through Southeast Asia and eventually reached the Pacific. That framework is not wrong, but it was drawn at a resolution too low to capture what was actually happening along the eastern route, and the Solomon Islands genome has forced a significant increase in that resolution. The migration was not moving through empty space. It was moving through a landscape occupied by archaic human populations that modern humans encountered, lived alongside, and interbred with across thousands of years in multiple separate events. The clean dispersal map had no room for that. The DNA requires it. The number and location of Denisovan interbreeding events has been revised upward as sequencing technology has improved and more genomes have been analyzed. The picture that has emerged is not of a single ancestral encounter at a single point in time and space. It is of a series of contacts with genetically distinct Denisovan populations at different locations along the eastern migration route, each leaving its own traceable contribution in the Melanesian genome. The Solomon Islands did not just preserve evidence of one lost chapter. They preserved evidence of several. The genetic foundation of the Lapita expansion and the origins of Polynesian ancestry have both been substantially revised. The early Lapita individuals were not the mixed population the standard model assumed. The admixture happened after their arrival in near Oceania, as Austronesian newcomers and long-established Melanesian populations spent generations in proximity and produced something neither ancestry had been alone. That mixture became the founding population for the settlement of remote Polynesia. The Solomon Islands genome is the clearest surviving record of the biological context in which that founding event occurred. None of these revisions are abstractions. They exist inside living people. The 700,000 inhabitants of the Solomon Islands today carry in their DNA a biological archive that no other population on Earth possesses in the same form. The Denisovan ancestry is there, the deep Melanesian founding signal is there, the traces of the Lapita admixture are there. 30,000 years of continuous human presence in one of the most remote and demanding environments on the planet, recorded not in stone or pottery, but in the genome of a living population, available to science because those people survived everything that was done to them and remained. The geopolitical present sits uncomfortably alongside that fact. The Solomon Islands today are caught between Australian strategic interests and expanding Chinese influence, the government having signed a security pact with Beijing in 2022 that alarmed its traditional Western partners considerably. The economy remains among the most fragile on Earth. Infrastructure is inadequate. Access to clean water is not guaranteed in significant parts of the country. The islands are exposed to earthquakes, tsunamis, and cyclones with a regularity that a more resourced nation would find difficult to absorb. The quiet argument the science makes, stated plainly, is this: the Solomon Islands are not a peripheral concern. They are not a minor entry in the ledger of Pacific geopolitics or a humanitarian footnote to be addressed when more pressing matters allow. They are the location of the most important surviving human genetic archive in the Pacific world. The people living there are not the remnants of a story that happened somewhere else. They are the story. And the world is only beginning, very late, and with considerable debt already accumulated, to understand what that means. The Solomon Islands are still there. Remote, beautiful, largely unknown to the world that has repeatedly found reasons to want them without ever truly seeing them. 900 islands sitting in a stretch of ocean so vast that the distances stop, meaning anything to a mind trying to process them. The people who live there arrived 30,000 years ago, before the sea rose and made islands of the land they walked across. They encountered archaic humans whose existence science barely suspected. They absorbed a wave of Austronesian settlers, and in doing so, helped assemble the ancestry that would go on to populate the entire Eastern Pacific. They survived colonization, slavery, and a world war fought on their shores by people who had no particular interest in them. And through all of it, they carried something irreplaceable inside them. The ocean kept the secret. The DNA preserved it. The people never left.